Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on network security, or NX, alerts. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our speaker today is Guy Plunkett. Guy is a principal training instructor with over 20 years of experience in cybersecurity. Before joining the training team, Guy has worked in customer support, engineering software and hardware, as well as infrastructure networking. Ladies and gentlemen, Guy.
Thanks, Nick. Hello. My name is Guy, and I'm going to take you through some introductions into our NX alerts. Now, before we get into all the NX alerts, it's worth talking a little bit about where an NX sits in the environment. So take this example here. We've got a network security device, the NX, and it's sitting directly in the path of the traffic coming from the internet to a client in the environment. What we have here is the NX is capable of watching all of that traffic passing down to those endpoint clients. And so if an endpoint device ends up requesting a malicious content, what happens is the NX will see that. And the NX is going to take a copy of that traffic and let the original traffic carry on down. Now, if the NX knows already that the requested destination that we're trying to get traffic from is malicious, it recognizes the URL, or it recognizes the IP address or the domain or something like that, then absolutely the NX is in a position and capability to block that request. If, however, it doesn't have that intelligence just yet, then it has to let the traffic through. We are long gone from the days of modems and dial-up and taking a long time for a website to download traffic. We're in an instant world, and so it's not possible for the NX to hold up that traffic while it performs its analysis. Instead, it will let that traffic pass through to the endpoint client so they get their immediate satisfaction of seeing those pages. But we're going to take a copy of that data, and then we're able to analyze that data in our environment. So if it's a binary file coming down, we're going to let that binary file pass through to the endpoint client. And as it's passing through, we're going to keep a copy of it so that when we've got all that file down, we can then start analyzing it. And it's only at that point, once we've got that full data through, that we can begin the analysis. Some things we can do straight off the bat. We could do a hash of that binary file. Do we have that hash already, again, known to us? In which case, great, we can get away with straight away analysing that and saying, this is bad, here's our references to it. If, again, we don't have that knowledge, then what we can do in our NX is we can run it through our virtual execution engine. This is a virtual environment we have designed for the specific task of running malware analysis. We can start up a virtual machine within a second or two and have it available to us for our analysis. The NX will automatically pick the most appropriate MVX engine to use. So we do that by looking at the headers of the requesting traffic. So the client, when it sends out a HTTP request, includes a header. And part of that header is identifying what the browser and the client PC is. So are we a Windows? Are we a Mac? Are we Linux? What browser are you running? Are we running Edge? Are we running Firefox? Are we running Safari? Are we running Chrome? All of those things are identified in the headers. We can look at that header and then make a judgment call on which virtual execution engine is the most appropriate to start in order to perform this analysis that's going to closely match that endpoint client that received this traffic. And so we can push this traffic into this virtual execution engine, replay that traffic in there, and then we can watch to see what that virtual execution engine does now that it's got this binary to play with. Does it try and make a connection to the internet? Well, if it tries, it's not going to succeed. What we're calling sandboxing, we're going to firewall that away. It will appear to itself to succeed. We're going to fake those network connections. So if it tries to go out to a remote website, we're going to pretend to let it get on and do that. Again, because we have grabbed the traffic from a real client making that request, we've captured not only that binary file, but any surrounding activity, which could include that surrounding follow-on request, in which case, again, we'll replay that follow-on request back to this virtual engine. If, however, we don't have that follow-on traffic, then the NX will make it up, will fake it, will provide fake destinations, fake results, fake binaries to download, and make it look like the ones that this binary is looking for. This allows us to see and observe all of that play out activity that this virtual machine may want to try and do while it's running this binary file. And this, of course, gives us the greatest advantage because we can see all of that activity, and that's what we want to happen. We want to give the malware every opportunity to demonstrate its badness. So we're not going to be turning on firewall security and so forth inside our virtual execution engine because we want to see it play out. We want to see that activity perform. Once the MVX engine has observed all that activity, whether it's processes being started, files being created, files being downloaded, registry keys being changed, all of this activity is being captured in our virtual execution engine without any human interaction. And that's the other key thing here. The virtual execution engine is letting this binary work and observing what it's doing without any human interaction. So this is what would happen on your PC if you executed this binary and just let it get on with it. And that's the key thing. Malware will happily go and install things, make changes and so forth. Legitimate software should be presenting a dialog box back to the user saying, is this okay to perform? I'm about to install this file. Can I do this? And illegitimate software won't bother with those questions. So again, gives us that advantage. Once the analysis is complete, we're now in a state where we have got our knowledge. We know what's happened. We've created ourselves a report of activity. And this leads back into the NX's self-governing service. Because at this point, we can now create some rules based on our intelligence that we have gathered. So if we determine this file is malicious, we can now create some rules. And those rules could be simple things like the URL that this binary came from in the first place, the domain name, the IP address, the parameters if it was a get or a post, what those might look like. It could also be looking for the hash of that file. So next time we see that file, maybe it's renamed, coming from a different location. Doesn't matter, we've got the hash now. Now we see that. If we see the hash again, we know it's malicious. And so these rules will automatically update into the NX so that the next time round we can be a bit more faster in our analysis. And that's what we're trying to do here is accelerate our learning to make sure that every time we're in the optimum place to report on that activity. How many virtual execution engines can you run in an NX? Well, that's a function of how big an NX you decide to deploy. Typically, that is again a discussion to be had, and it's typically observed with the amount of bandwidth you have. So if you are running a small bandwidth environment, you might need a small NX, because there's a limit to how many concurrent downloads, how many binaries you're going to be getting through at any time to need to analyze. In a very large environment, you may have a very large NX where you can run multiple MVX engines in order to allow you to deal with that concurrency that the bandwidth demands. We have a number of different ways of supporting that scalability. As I say, we can put bigger boxes in, but we can also create clusters of virtual execution engines, either local or in cloud, and then have what we call NX sensors do that analysis and data capture, and then feed off to the virtual execution engine cluster for the analysis results. Either way, whether we separate them out or not, the traffic follows this simple path. Fast path is wire speed. As that traffic is passing through the network, we are watching it, we're observing that activity, we're looking for that URL, that domain name, that IP address, and if we identify that, we're going to block it. We can alert and we can block. Next is moving into that static and dynamic analysis we talked about. Static, simple things like the hash of the binary file, which we can only do once we've got the full binary down. We may also do some Yara analysis as well on that binary file. But at the same time, we could be starting up our dynamic analysis engine and then playing that virtual environment through. At the end, we can generate those rules so that next time round, we don't need to run the dynamic analysis. We could be blocking at the fast path side or straight away at the static analysis. As soon as we've seen that full binary come down, we can do a hash, recognize the hash. This is malicious, block. So this gives us a great way of immediately accelerating our learning, and it's a constant cycle. Now, once we've conformed our analysis, we've created our rules, we are also going to report back to the administrator, the Security Operations Center, about our findings. And we can present that back in a number of different ways. So by the host, individual IP addresses. Here's a severity score, total number of malware we've seen or infections attacks we've observed. And you can see here we've got the infection count, we've got how many callbacks, which is obviously that communication from the client PC back out to the internet. Those are obviously deemed as most severe and serious because that's communication from the client PC back out to the internet. At that point, we could have data exfiltration going on. We could have this secondary communication channel pass setting up, etc. And so we always give that a critical severity score. And it is the callbacks that we're likely to be able to block. Again, once we've done that MVX analysis, we have those rules ready to take into account for that. And so we may be at a point now where we see that activity, we've observed it in a virtual execution, now we're seeing it on the endpoint client, and so now we can go straight away and say, yep, we see that communication attempting to talk back again, and we're going to block it. We can also flip it around and show a list of alerts. So what is alerting in our environment by the malware type or the times and so forth. We can then resort those alerts. Again, gives us a different view, different perspective. You might have multiple alerts to that single one host, but you might also have the same alert going to multiple hosts in your environment. And then, of course, finally is the callbacks, where we definitely want to be observing those and looking. And again, we might discover by looking at the callback listing that we've got dozens of callbacks, but they're all going to the same destination. Or we could observe multiple destinations coming through for those callbacks. And again, it could give us the opportunity to add those IP addresses of those callback servers to our proxies or firewalls. So belt and braces, not only is the NX now blocking that traffic, but we can add it into our other security products, maybe other products around our network infrastructure that are now going to be blocking or reporting on that activity. Again, worth adding those extra things in there if there's a possibility that devices might circumnavigate the NX. Maybe you haven't got the NX fully deployed in all parts of your enterprise, at which point you might be looking to add those in there. So let's just take a look at the different alert types that we can get out of the NX. The most simple one is that infection match. Infection match is simply as it says. We can match. We observe the client PC making a request to a URL, and we recognize that URL as malicious. So we have observed that in the past, either from security content updates or from our own NX analysis. We've observed that URL is malicious. We observe you trying to go to that destination again, and the NX can say no and put a block on that request. The NX will still generate an alert to say this was attempted, but that's as far as this attack will go because it is being prevented from performing. Obviously, the attempt was made, and so we probably do want to have a discussion with the end user to discourage them from going to that destination again. We've seen them do it once. It may have been inadvertent, it may be an accident, but it's worth reinforcing that with the user. Web infection and malware objects are attacks against the client, and we've had that come down to those PCs. Web infection is against the browser. So that could be a plugin in the browser, so something like Silverlight, QuickTime, and so forth. Adobe Reader, PDF is often bundled inside the browser these days. Flash, yeah, absolutely. But of course, as we all know, Flash is pretty much gone now, so it's less likely to be an attack, but nevertheless, we're still observing for it. Malware objects are the binaries themselves coming down. So those could be, any file coming down is a binary object. So even a text file is a binary object. In this instance, we're more likely talking about executables, Word documents, PowerPoint presentations, Excel, graphics, GIFs, TIFFs, and so forth. Anything like that might be coming down. PDFs are a good example where it's a bundled object. PDF, obviously, portable document format, looking at those standard documentation, but unfortunately inside a PDF we can have binaries, we can have JavaScript and so forth executing, and we're going to analyze that. So binary object is any binary file that comes through and that we then end up analyzing in our virtual execution engine or observing through our static binary analysis. So at that point, it has come down to that endpoint client. So there is malware on their client PC. We've observed that passing through. We'll generate an alert about that fact. And so obviously then there is a need to have a conversation with that endpoint client and that user to remediate that binary object. It is possible, and often the best state is that you have an alert to say a binary file came through, but when it comes to it, you look at the client PC, you can see, well, actually, the client isn't vulnerable to that binary attack. Either it's got additional security products in place, or it's been patched, and so is no longer at risk of that attack. We still want to alert, we still want to tell you that this occurred, because, of course, it could be passed to somebody else. He could forward that around. He could put it on the file share. He could send it off to somebody else. We don't want that happening. So we're going to always tell you that this alert has occurred, and you can then do your follow-on research about that. Domain match is where we see a DNS query. Now, will the NX see DNS queries? That highly depends on where the NX is deployed in your infrastructure. Typically, in an enterprise, you have your own internal DNS servers, and they will be responsible for answering those DNS queries that come out. And so it is possible that the NX won't see those DNS queries. If, however, it does see the DNS query, and that DNS query is known, so the domain we have knowledge of as being malicious, but in this instance, the DNS query results in no entry found, so doesn't get a TXT record or an A record or a CNAME or any other record being returned, then you'll get this domain match alert coming up. So we know the domain is malicious, but it didn't resolve in an answer. Then you will get this alert. What that tells you is the client PC is obviously trying to make those DNS queries, but it's not succeeding because the DNS records are not coming back. That might be because the DNS server is actively blocking those requests, but it could also be that the domain registration people have already removed that DNS from the records because they've identified it as being malicious, or the domain is too new and hasn't yet propagated through the network and you're an early adopter of this malware sample. So again, worth potentially investigating a little bit. And really what's worth investigating is that endpoint client that made that DNS query in the first place. Why did it make that query? How did it make that query? Because if it's that new, then what's happened on that PC to make those DNS queries? If it's old one, then you've probably got some latent malware sitting on that PC beaconing or attempting to re-establish itself, in which case it is probably worth going to remediate that machine in the first place. And then finally, of course, is that malware callback. That's the communication back out from the client PC out to the internet. At this point, we are running binaries, malware on that endpoint client, which is trying to communicate with the wider internet. The NX, again, is in a position where it could be blocking this communication traffic and reporting on it. And clearly, it is critical at this point because we could have command and control communication going on, or data exfiltration or preparation of data exfiltration in the endpoint. And so we definitely want to get to that endpoint PC and review that activity and prevent any data breach from our environment. So you probably noticed on the NX these little icons on the side during our analysis. What are they? Well, these tell us what analysis we performed and the results of that. So where the NX has analysed some traffic, we've created a report. These are the summaries of what's in that report. So the little icons tell us the different things that we analysed, judging by whatever happened. So it could be simple things like here's a screenshot of the activity on that virtual machine, all the way up to here is what we call the OS change reports and change graph. And we're going to go through these. So let's have a look at a real NX that's generated or presenting quite a few alerts to us. Here we can see, as you see, we've got lots of alerts. We've got lots of objects, malware objects. These are binary files coming through. So we've got executables, RTF, rich text, documents, Word documents, docx, obviously, coming through as well. PowerPoint presentation down there, and so forth. And over here on the side, we can see these artifacts of our analysis. So let's go and click into one of these. We'll start off with the rich text file. So we'll just go and click into that. There seems to be a few artifacts presented. So here we can see the summary of the alert that's been generated. So first of all, worth noting, we've got a name for it here. Now, the NX won't make up names. We will try and reference other people's names. So if this is a known malware binary, then we've probably got a name for it from there, in which case we'll give it that name. Otherwise, we tend to give it generic names and worry about naming later. So just because you have a generic name coming up doesn't make it any less malicious. It purely means that we haven't identified it as part of a specific malware family yet. So that could be because it's very new. It could be an APT or something that hasn't yet been observed to get an official name yet. In this case, we do have a name, so we could obviously do further research against that name. In this case, of course, it's Microsoft Word that opened this up. It's a rich text file, and we can see here the client PC that made the request, where we got it from, and the port we use. So in this case, just HTTP port 80. This is my sample server, which hosts lots of malware. So in this case, we've allowed this machine to pass through, which is why you can see here we've not blocked. That's us reconfiguring it to exempt this one through. Typically, it would be blocked. Now, we have two reports here. We have bot communication and VM communication. VM is what the virtual machine performed. So when it ran this analysis, that is what we observed the virtual machine doing. And so here we can see we've got a communication going to pastebin.com and making a GET request for this location on Pastebin. What that might be, I don't know. It could be a secondary binary to download. It could be the exploit to carry on. So there is clearly an additional file to fetch. Now this makes a great IOC, indicator of compromise, because I can now perform a search in my enterprise, in my proxy logs and so forth, looking for this URL and see if anybody else has made that request. Now, earlier we talked about the bot communication. What is the bot communication? Well, the bot communication is what we observed happening from the endpoint client. So as part of the NX's capture, we captured what the endpoint client did as well. And in this case, we can capture the request for the traffic to the based bin. So we have that file. So it's here, and we could go and grab that back again if we want to. It is available to us in the PCAPs here. We can go and download the PCAP and access it. We've also got access to the original malware that we're analysing here, and again that's in a zip file. The zip file is password protected. It's password protected not to stop you accessing it, but to make you stop and think, am I accessing this in a safe location? We obviously don't want to exploit other PCs during our analysis of this malware. So just stop, think, am I analysing this in a safe location, in a virtual machine or a controlled network where it is safe to detonate this malware? It's not going to then cause more risks. We've got the headers of the file of the process that did the download. In this case, it's an automated task, so we used curl to fetch the binary down from my sample. So we didn't actually run a browser per se. And then down here we've got the OS change report, and you can see we actually ran it through two virtual machines. We ran it through a Windows 7 machine, and we ran it through a Windows XP. But wait, Guy, why are you still using XP? Surely XP's dead. Well, yeah, you'd like to think so, wouldn't you? No, we still see XP floating around in enterprises, specifically embedded devices in enterprises. It is also a great OS to use because it is the one with the most vulnerabilities in it. It's got lots of exposed, well-known exploits. And so if we want to give the malware every opportunity to demonstrate its badness, we want to pick OSs that are going to offer that to us. And so XP does. You can obviously disable these different versions of Windows if you wish, but think about this. If you disable the XP or a version of Windows and say, well, all my environment is Windows 10 or 11, therefore I'm only going to analyze malware for those versions, you will likely get fewer alerts because, of course, they won't be detonating on those versions necessarily. What that means is that malware samples may be coming through your environment and not getting reported as malicious because they're having no effect on your endpoint and the engines that would detect them have been turned off. That allows the attacker to carry on running malware at your environment until he does get success. Instead, if you have these lower OSs that are more vulnerable preparing to detonate and report on malware, it may not be effective in your environment, but that's perfect because that means you saw their attempt and you can take remedial action to protect the environment against that. Stopping somebody going to that website. It could be making sure, just quick review of your security prospects. Could be sending out an email to people saying, hey, keep an eye out. We've seen these attacks. They're not having any effect because our security is up to date, but be mindful. You know, you can actually take advantage of knowing these attacks are occurring in your environment and prevent it, rather than doing something after the fact when they've had success and then they are alerting you. That's not a good state to be in. So keeping the old stuff around has benefits. Now, if we have a look at the OS change report, let's have a look at the Windows 7 OS change report. And first of all, I quite like looking at the graphical interface. This gives us a simple flow chart of the activity observed when we analyze this binary file. And so we can see here we started up Word. Word then was persuaded to perform some DNS queries, obviously to pastebin, to look up for pastebin domain. And then we've got this network request to go and fetch this file out of pastebin. So immediately we can start to identify some interesting activities. Now, what we can also do is dive into more detail. If we look at the event distribution, this gives us a blow-by-blow report of activity observed. At the top, we have these spheres, and the sphere's size is relative to the number of events within those spheres. So if I just want to get a summary, I can just click on malicious alerts and we'll get all the text associated. So this is human readable activity observed. So we've read out the activity observed above and given a little readout. So here you can see we've identified the malware. We've got DNS being observed from that process, from that rich text document running that. And then, of course, pastebin. We all know risks associated with pastebin, so we've actually got to pull out for pastebin itself anyway. So that can give us a nice, great summary to look at, sort of the executive view, if you like. But if we take that off, we can actually see a blow-by-blow account. So we can see the process being started by the malware analysis. Now we've got some exploit code being executed. And then we can see further down here, we've got files being opened, DNS queries being made. So we've got DNS query for pastebin.com. In this case, we give a fake DNS IP address resolution. 199.16 is us, it's Trellix. We fake that IP address back so that we can then observe that activity. So this is not a good IOC. You won't observe that in the wild. And then here we can see the file being created. And every time the file is created, modified in any way, we're going to give you a hash of the file. So we've got the MD5 hash and a SHA-1 hash. These would make good IOCs. So we could grab the IOC from this file and do a search for that. We can also look for this location on those endpoints as well. And then again, we've got API calls being made, in this case, just looking in the clipboard, and dialogues being detected and dismissed. So automatic closing those dialogues away. So what should be being presented to the user and allow the user to acknowledge that dialogue is automatically being dismissed by this malware sample. So let's have a look at this one here. This is Emotet. Again, we've got our name at the top. We've got the details of the client and where it came from. We've got the hash of the binary file that was observed coming down. And then down here, we've got that communication again. So the client PC made these requests. So again, we can go look for that. And in fact, here you can see we've got the client request is a post, and here is the data being posted back. And we could do some work to decode some of this data. Looks to be maybe base 64 encoding, and so we could go and work to decode some of that data for further analysis. But we can see here all the follow-on communication from the endpoint client that's observed. And again, all of these would be well worth further investigation. We've got lots of IP addresses here that have occurred from that endpoint client. We can also look at the same activity coming from our virtual machine. And again, we've got these post requests and the data being posted back. And so we can again look for that correlation there of activities. And again, pick out these IP addresses, which we would then make use of in our IOCs, indicators of compromise, that we could add into our rule sets for further investigation and analysis. Again, looking in the graphical flow, this one's a little bit more in depth. And here we can see activities observed. Again, we've got a macro being launched. We've got some registry keys being queried, this time just for computer name. We've got API calls being made, get the computer name. We've got processes being launched. We've got HTTP requests coming on down here. So we've got a post to task merger going on. We've got a PDF being posted to apparently here as well with additional data and so forth. If we go across the event distribution, we can get more in-depth detail about that activity. So if we scroll down again, we can see the activity observed, and here we can clearly see the work being done. We've got all these API calls being placed to try and find our working directories, and so forth. If you don't know what an API call is doing, we can obviously just grab the API name and search against the Microsoft Developer Network database, and that will give you those API calls and the parameters that are being submitted. Typically, it's a memory location and size, which is what these two are for the results of that query. So we can track what those are. This one's a bit more in depth. Create service work, and we want to figure out what that is. So here we can go and have a look for that one, and then here we can see those details. So it looks like we're creating a service to start for this process here, source targets.exe, and that's being set up. And then here we can see we're modifying the registry keys associated with this new service that's been instigated or configured. And we can see here we're making adjustments to make that service operational. And then down here we can see we've got again trying to run that, get that service operational. Let's see what else we've got further down. There's a registry key changing the connection settings. So manage how it's going to how it's connecting to the network. Cookies being managed as well for it. Proxy, turning off the proxy. So we don't want to use the proxy to get to the internet. We're going to go straight to the internet. So again, potentially trying to bypass security facilities in the enterprise. And then here we can see a whole bunch of network requests being instigated by this source targets process, which has been placed into that system directory. So we've got the IP address and the port 8080, so non-standard, often used as a HTTP port, but obviously not the standard port. And so we could again go grab all of these IP addresses and add those into our list of intelligence that we're searching for associated with this malware sample. Okay, that's a very brief whistle-stop tour of our NX and reviewing some of those NX alerts. And with that, I will hand back to Nick, as I think we have some Q&As to go on now. So back to you, Nick.
Thanks, Guy. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on your screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated.
So can you submit binary files for analysis?
Binary files for analysis? So with the NX, no. You can't submit a binary file directly to the NX. The only way you could do that would be to force it through as a network stream. The AX would be the right device for that. That's often deployed in a security operations center for research. And with the AX, you can absolutely upload a binary or point it at a URL. And in fact, you can customize a little bit how the analysis is performed. You can request screenshots. You can even interact with the virtual machine while it is performing its analysis and get that interaction. So if you needed to click on a button or perform an action to have the malware perform some work, then with the AX you could absolutely do that. But no, that's a separate product would allow for that.
Great, thanks for that. Okay, so where in the infrastructure is SSL or TLS decryption done in order to inspect the files traversing the NX box?
Great question. So many times, obviously, long time ago, everything was HTTP and we were all happy because we could see all the traffic. We've now moved into the model now where most traffic is SSL, and that's for a very deliberate purpose of trying to obfuscate what the traffic is, encrypt it. So there are two places we can do that. We can have the NX perform SSL termination and do the decryption and then re-establish the encryption the other side of its connection. So if you wanted to, you can absolutely put a root certificate onto the NX and have the clients pretend to terminate to the NX. The more common route is actually to do the SSL decryption on a proxy and then have the proxy pass a unencrypted feed to the NX to perform its analysis. So either works for us, but as I say, the most common is to actually use a proxy to do that decryption because you're probably doing that already.
Great, thanks for that, Guy. So to what extent is the NX technology relevant for networks with unmanaged clients versus managed clients? And then follow up to that, what does not work for unmanaged clients?
Excellent. So the NX, because it's in the network stream, really doesn't interact with those endpoint clients. There is no, other than that HTTP or that network traffic that the NX is observing, there is no back channel back to the endpoint client.
So at that point, it doesn't matter whether the endpoint is managed or unmanaged. The NX is just seeing the traffic on the network stream and analyzing and reporting against it. Now, obviously, if you have a managed device and maybe using the Trellix HX, our endpoint security device, then the NX can send its alert information to the HX, and the HX is then capable of looking at that alert information, generating some rules, which it can then push down to the endpoint clients that are being managed by it. And those endpoint clients are then able to look to see if they performed the work that we've observed across the network. So if you've got a very large infrastructure, a few 100,000 PCs, it's very tedious if you get an alert on the NX, this IP address tried to go to this website. Okay, now I've got to try and figure out who had that IP address at this time. That's doable, obviously, but it may be a bit of work to achieve that. With the HX in place, the endpoint will actually raise its hand and say, it was me, it was me, it was me. And so at that point, you've now got this correlation between the alert observed on the NX, which it generated an event. The event has then been passed to the HX. The HX has then said, created some rules to find the appropriate endpoints. All endpoints in the infrastructure have updated with these new rules. And now each of those endpoints has gone through their recent history to see if they did that work. And so we might get one machine alerting, but you might get 3 or 4 because somebody did it outside of the network. Maybe they did it in Starbucks an hour ago. Now they've somebody has done it inside the corporate network. The NX has observed it, generated an alert, produced a set of rules, which the HX has then put down to that endpoint. All the endpoints in the infrastructure have now received that new rule set, and now they're all snitching on the the PCs that perform that work. And so you might get lots of the events reported directly on those machines. So it can work in either way, but obviously the more value is when you have that HX in place as well.
Great. Thanks for that, Guy. So can you monitor multiple networks?
Absolutely. So depending on the size of the HX, depends on how many network interfaces you have, and also depends on how you want to deploy. So the NX can be in an inline mode, which is what I was showing earlier, where we're using 2 interfaces and watching the traffic as it passes from one network interface to another to go out to the network. Other modes are tap, where we actually only need one interface and we're just taking a copy of that traffic off that tap interface. That could be as simple as a port mirror on a switch, or more powerful tapping devices such as a Gigamon or something like that. Then we can take those streams and perform that analysis on the NX. So it really depends on how big an NX you've got as to how many network interfaces you have, and therefore how many concurrent virtual machines you can run in order to perform that analysis. What you don't want to happen is the NX to be receiving too much traffic for the number of virtual machines that it has available, and so it ends up queuing up those virtual machine analyses to be completed. That's never a good state, because then you're always behind the curve. You want to get your analysis done as efficiently and as quickly as possible. So at that point, you want a bigger box or additional boxes to handle that extra load.
Great. Thanks, Guy. Can I integrate the alerts with other systems?
Yes, absolutely. The NX has a number of ways of getting the alert information out. We have webhooks available. So as an alert is generated, we can do a HTTP post to another system, and then you can obviously deal with that as you please. So as long as you've got something that can listen to HTTP and is going to listen to the JSON or XML data, you choose which you want, you can action on those alerts in real time.
Great. Thanks, Guy. So we had one more come in here. It says, may I know how long is the alerts retention?
Forever. Yeah, we don't expunge the alerts out of the NX, so they can be in there for many, many years. What we will expunge is the binaries associated. So if we did a binary capture, then over time, in order to maintain disk storage capacity, we will expunge old binaries from the system, so old packet captures and so forth. But the actual alert information is retained in the database, and that's there for very, very long time. In fact, I'm not sure when we do expunge that, if we do at all. It is micro data at that point, and our disks are fairly large, so it's there for forever as far as you're concerned. You can do backups. It is a SQL database inside there, and part of the backing up is getting that alert information back out again.
Great. Thanks, Guy. Well, it looks like that's all the questions we had for today's session.
Excellent.
I want to thank everyone for joining today's webinar, and a big thank you to you, Guy. Appreciate you. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. This concludes today's webinar. Stay safe, everyone.
Thank you very much.
Thanks, Guy.